Hi everyone, welcome to AI Tech channel. This is Akash Gangwar and today we'll be studying Indefinite Integrals lecture 3. So we'll be continuing our discussion about substitutions and we'll start with the standard integral derivation part 1. So basically we studied about certain standard integrals which were different as compared to the elementary integrals which we studied earlier, and let's look at the derivation part 1. So this is for dx divided by under root a square minus x square. So the obvious substitution over here is x equals to at, because we want to have a square as common over here. So that's why standard substitution over here would be x equals to at. So dx would be a times dt, right? So this would give me a times dt divided by, we'll get a as common over here, and in under root we'll be getting 1 minus t square. So this gets cancelled out. So this eventually becomes sine inverse t plus c. Now t was x by a, so that means this was sine inverse x by a plus c. So that was a pretty simple derivation. Now let us look at the part 2. We have to find out the integral dx divided by under root x square minus a square. Now in the previous case we had a square minus x square, so we converted into a simple format, but this is not a standard format, right? So that is why we have to make a trigonometric substitution over here. So in this case, the ideal substitution would be x equals to sec theta, a sec theta actually. So that would give me, dx would be a times sec theta tan theta d theta, right? So this would give me a times sec theta tan theta d theta divided by under root a comes out, and this would be sec square theta minus 1. Now this gets cancelled out. Sec square theta minus 1 is actually tan square theta, and with under root over it, that becomes tan theta. So we have sec theta tan theta divided by tan theta d theta. This gets cancelled out. So this eventually becomes integral sec theta d theta. We all know that this is nothing but ln sec theta plus tan theta plus c. Now we have to make the replacements. We have sec theta as x by a, right? So we have x by a as sec theta. Also, we have to find out the value of tan theta. Now we know that sec square theta minus 1 equals to tan theta. So basically, x by a whole square minus 1 under root equals to tan theta. We can write this as ln x by a plus 1 by a times and root x square minus a square plus c. Now we know that this a is a constant number, and with the property of log, what we can do, we can write it as ln x plus under root x square minus a square minus ln a plus c. Now we can club both of them in a new constant called plus c dash. So that's the derivation part for this one, right? Now let's look at this example. We have integral sine 2x dx divided by under root 16 minus sine 4x. Now we can clearly see that we want something of the sort a square minus x square over here, or a square minus t square over here. So the obvious substitution over here would be sine square x equals to t. So that would give me, and also if we differentiate this one, we'll get sine 2x in the top. So that also gives us hint that we have to take sine square x equals to t. So that would give me 2 sine x cos x dx equals to dt, right? So this would give me integral, this becomes dt. 2 sine x cos x is nothing but sine 2x. This becomes dt divided by under root 4 square minus t square. Now this becomes the standard format for sine inverse. So this would give me sine inverse x by a, t by a, t by 4 plus c. Now replace it with t, sine inverse sine sine square x by 4 plus c. So this is the final answer. Now let us talk about certain standard methods of integration. And actually these are not standard methods. These are just the continuation of whatever we have studied in the standard integrals which we derived with the help of substitution. So that's why we are studying them after substitution. Now let's look at the first part. It says that whenever we have these two kinds, basically dx divided by some quadratic and dx divided by some under root of quadratic, in that case, what our approach should be, ax square plus bx plus c should be perfect square. We have to make in such a format that we have to create it as a perfect square. For example, dx divided by a square plus x square. We all know that this is nothing but 1 by a tan inverse x by a plus c. Let's say we have dx divided by a square plus x plus 2 whole square. In that case, our answer will slightly modify. That would be x plus 2 divided by a plus c. So this is how our answer would be for this particular case. So we have to convert this format into this format only. So basically ax square plus bx plus c would be something of ax plus b whole square, not exactly x plus b. Let's say ux plus y whole square plus some k square. And then we can do this particular thing. Similarly for this one, we can again convert into similar kind of perfect square and a constant square. And then we can use the formula of dx divided by under root a square plus x square, right? Now coming to the second one, px plus q divided by ax square plus bx plus c. In this case, what we have to do, we have to convert the numerator as a derivative of the denominator in both the cases, in this one as well as in this one. So we'll see with the help of an example how to proceed with this one, because it's not a simple one. It's not a shorter one basically. This one is pretty straightforward and shorter one, but this is not a shorter one. It can take a little more time. So we'll see both of these with the help of an example. Now, one more thing, it's not just for this one, these ones. We can also do for the sine inverse ones also. This one was for tan inverse. This one was specifically for dx divided by under root a square plus x square. You can also do the same for dx divided by a square minus x square. That would also work exactly similar in a similar manner. So basically dx divided by a square minus x plus 1 whole square, let's say. In this case, that would become sine inverse x plus 1 by a, right? Now let's look at one example. The value of integral dx divided by under root 4x minus 3 minus x square would be. So basically this is the case of sine inverse x, because we have minus x square over here. So dx divided by under root 4x minus 3 minus x square. So with the help of 4x, I can clearly see that this is nothing but x minus 2 whole square. So that would give me under root minus of x minus 2 whole square. So this would have x square with a minus sign, minus 4 with a minus sign, but we have minus 3 over here. So I'll add 1 over here as well. And 4x minus 4x with a minus sign, that would be 4x. So we have 4x over. So this is nothing but dx divided by under root 1 minus x minus 2 whole square. So this will eventually become sine inverse x minus 2 divided by nothing, because we don't have any coefficient over here, plus c. Sine inverse x minus 2 plus c. So D would be our answer. Now let's look at this illustration. So this is the part of second example, second case, this one. Let's see how to proceed this one. So we have integral 5x plus 4 divided by under root square plus 2x plus 5. So the first task is to calculate the derivative of this one. So for differentiation of this one would be 2x plus 2. So we have to convert the numerator as a part, as a factor of this one. So I can clearly see that I would write the numerator as 5x plus 5 divided by under root x square plus 2x plus 5 plus not plus minus dx, basically 1 dx divided by under root x square plus 2x plus 5. Now this becomes the standard part which we saw earlier. Basically will be what we'll be doing, x plus 1 whole square plus 4 plus 2 square. So basically this would become x plus 1 whole square plus 4, basically 2 square, and this would become ln of x plus under root x square plus a square, this kind of format, not exactly x plus 1 over here and x plus 1 over here as well, but this kind of format, this one will become. So this became the standard integral. Now for this one, I'll write this one as 5 by 2 times 2x plus 2 integral. Let's take 5 by 2 outside, divided by under root x square plus 2x plus 5 dx. Now I'll be taking x square plus 2x plus 5 as t square, right? So this would give me 2x plus 2 dx equals to 2t dt. So basically I'll be getting 5 by 2 integral 2t dt divided by under root t square. So that is nothing but t. So t gets cancelled out. This gets cancelled out. This becomes 5t. So what we are getting eventually, t is nothing but x square plus 2x plus 5 under root. So 5 times under root of x square plus 2x plus 5. So for this integral, we have got this value. And for this integral, we have got the other value, right? So this is how you have to proceed this particular example. This becomes a little lengthier, but it's a very standard approach. So today's lecture was till here only, and in the last lecture we'll be studying by parts and partial fractions, and that would be the end of indefinite integration. After that we'll be starting with the last chapter of calculus, definite integration and area under the curve. So let's meet tomorrow. Thanks for watching.